Good morning, all of you. So let's start today's class. So today we will learn reversible and irreversible process. Okay, reversible and irreversible process. In the last class, we have learned quasi-static process as well as second law of thermodynamics. So let's see what is this reversible and irreversible process. Reversible process. The process, see, in name itself, what it is saying, reversible. Reversible means which can be retraced back. Okay, so see here, I am writing the definition. Process which can be retraced back. Process which can be retraced back. They are asking this question for 2 mark. Okay, keep it in mind. Process which can be retraced back in such a way that the system passes through the states as in direct process and finally the system acquires the initial conditions. Finally, system acquires initial conditions leaving no change else. Leaving no change else. And any quasi-static process can be reversible. It's called reversible process. And any quasi-static process is reversible. Okay. Why any quasi-static process is reversible? Because see, in a quasi-static process, at each and every point, the system will be in thermally and mechanically equilibrium with surroundings. So there is no change. Here also reversible process. It is retraced back following the same steps of as in direct process, and finally there are no changes. They are not leaving any changes. Okay, that's why any quasi-static process is reversible. Yes or not? Let's see some examples of this reversible process so that you will understand better. Examples. Number one, ice into water. Ice into water. Yes or not? You see, first ice, water, whatever the states are there, same states are going to be followed. That is what reversible process. Change of state of ice into water. Next example, water to steam, water to steam. Just this is change of state. Okay, change of state. Keep it in mind. Change of state. Right. These are the two examples which I have told you of this reversible process. Okay, understand? This is what reversible process is. Next, now, what are the conditions for this process to be reversible? Right. First, note down this. Okay. So see here, conditions for a process to be reversible. Conditions for a process to be reversible. Conditions for a process to be reversible. So what are the conditions? Then only we can say that the process is reversible. That is what we are going to learn here. So condition number one, there should be no loss of energy. There should be no loss of energy. There should be no loss of energy due to conduction, due to conduction, convection or dissipation of energy. Or dissipation of energy. Against any resistance like friction or viscosity. Against any resistance like friction, viscosity, etc. Okay, so see what you understood from this. So see, let's take one example of car. Okay, car is moving on a road. So when car is moving on a road, there is one opposing force, that is frictional force. So there is some loss of energy. Next example we will take, suppose I have dropped a ball into liquid. Let us take oil or something like that. So whatever its energy is there, it will go on decreasing. Kinetic energy particularly I am talking about. Yes or not? Because of that viscosity, that viscous, how do you can say, drag or whatever it is. It will always oppose between the two layers of the liquid. So this should not be there. That type of loss of energy should not be there. That is your first condition for the process to be reversible. Second condition. So no heat should be converted into electrical or magnetic energy. Into magnetic or electric energy. So this is not allowed. There should not be conversion of this heat into electric or magnetic energy. This is condition number 2. And third condition, the system must be always in the system must always the system must be always in thermal, chemical and mechanical equilibrium with surroundings. Okay. Thermal equilibrium, chemical equilibrium and mechanical equilibrium. Already I told you definition. What is meant by thermal equilibrium? Means system and surrounding should have same temperature. Chemical means there should not be any unbalanced reaction. Mechanical equilibrium means what? There should not be any unbalanced force between system and surrounding. That is what your thermal, chemical and mechanical equilibrium means. So these are the three conditions for a process to be reversible. That is number 1, no loss of energy due to conduction, convection or radiation. Okay, against any resistance like friction, viscosity, all these things. Next, second condition, heat should not be what can I say, converted into either magnetic energy or electric energy. And third one, system should be always in thermally, chemically and mechanically equilibrium with surroundings. Right? Then only we can say that that process is to be reversible. Got it? Okay, next. Now, the reverse of this process, that is irreversible process. What is that? Irreversible. Irreversible means what? Ulta, hai na? Irreversible process. So how you will write this definition now? You can see here what I wrote here. A process which can be retraced back in such a way that the system passes through the states as in direct process, and finally system acquires initial conditions leaving no change else. Right. Now here in this irreversible process, what will be the definition? The process which does not follows the states which are in direct process, as well as the system or the process cannot be retraced back. Right. So I am writing like this. In this process, the system does not pass through the system does not pass through the same intermediate state as in the direct process. Okay, and most of the processes occurring in the nature are irreversible. Most of the processes are irreversible. जैसे कि let's see some examples. So some examples, see here. What are the examples of this process? Number one, diffusion of gas. Yes, diffusion of gas. Is it reversible? No, it is irreversible. Irreversible. Diffusion of gas. Second example, dissolving of salt in water. है ना? Dissolving of salt in water. This is also which process? Irreversible. Third one, sudden expansion or compression of gas. Sudden expansion or compression of the gas. These are the examples of the irreversible process. Right? These are the some examples of this reversible and irreversible process. Okay, so before we have finished this reversible, now it is irreversible. Right? So now from this chapter only heat engine, refrigerator, yes, and Carnot cycle is left. Okay, if we will start now heat engine, it will be late, we can say, or it will not finish in time. No problem. We will start it on tomorrow. But today I want to give some problems. If you will solve, then I will send you. Okay. Right. I will send you some problems. You try to solve. Okay. Okay. I will send you some problems. So you try to solve it. Almost today I will give CP and CV and their relations. Hai na? Already we have finished, no? So CP and CV and their relations problems we will finish. And then different thermodynamic processes also I will give you. Although class finished early, you immediately start solving the problem which I am sending. Okay. So let's stop here. Bye for today.